Hi, welcome to week 5. Does anyone have any questions before we start? Okay, I will take that as a no then. No questions. Okay, very explicit from Nick. Thank you, Nick. So, let's start talking about the actual built-in collections that are inside Kotlin. Now, we've already created our own list as one of the assignments, and there's a bunch of different types of lists, types of different ways you can do lists, whether you do a linked list or a doubly linked list, or using an array for a list, all sorts of different manners of handling lists of objects. Um, in Kotlin, we like to try to not refer to the class itself, the actual explicit class. So not you don't want to refer to array list. You don't want to refer to linked list. You want to use some helper functions that'll build those. And you do that something kind of like this. I could say val list. Actually, let me make a main here. I can say val list one equals list of, and then put some numbers in there or some strings or whatever you want. So the first way you can do this is if I just said list of string like this, that's going to be an empty immutable list of strings. And in this case, it's just going to be an empty. You can never and ever change it. And because you made it a val, you can't even point list1 to anything else. If, however, this list variable itself were a var, then it's an empty immutable list of strings. I'll say starts as, and you can change it. You can point it to something different. So you could later on say list2 equals list of A, something like that. Or you could say list2 plus that. Now keep in mind that whenever you say plus on a list object like this, you are creating a new list, which can be rather expensive. It's good for use in recursive functions. It's good if you want to parallelize things because you're actually creating a brand new list. You can't ever have two different threads messing up the same list at the same time. But it does have some overhead because you're creating a new list of it. Let's dig a little deeper to see what a list is. Yeah, we'll start with this. Let's dig a little deeper to kind of see what a list actually is and how it's put together. So what I like to think of is a list is a bunch of buckets slash pointers. The list structure just keeps track of pointers to things, or if they're primitives, values into primitives inside of it. And whenever you make a copy of a list, you're not actually making a deep copy. You're only copying the pointers to things. So copy only copies the bucket value. So whatever's inside there, it could be a primitive, like an int, or a pointer to something else. So if you have some huge objects that you're keeping track of in a list, don't worry about the huge objects themselves being copied. We're just making a copy of the container that's pointing to them. So it's fairly efficient. Keep in mind that if you follow those buckets to the object, they'll be pointing to the same object. So if you started off with something like a val x equals list of A, and then you say val y equals x plus b, it's actually going to copy the first element from x, since there's only one element in there. So the first element of y is going to be a pointer to that same string, A. Second element is going to be a pointer to a string B. And so it's the copy is it's expensive because you're making a whole new set of data structures, but it's not as expensive as you might think. You're not actually making deep copies of things. And I will say this is called a shallow copy. Now you can implement deep copies. You have to be really careful if you think about trying to implement a deep copy because if you have any type of circular references, you can spin off into oblivion. There are ways to get around that, and I'm not going to go into a lot of detail on shallow versus deep copies. But most of the time you want to think about shallow copies Don't recreate objects if you don't have to. And it's really, really useful if the objects themselves that you're pointing to are immutable. So if the values are immutable, there's zero harm here at all. Even if you have multiple threads looking at the thing at the same time, since they can't follow a pointer and then change something, you're safe. When you make these copies of the list, you're pointing to these objects that cannot change. If one person on one copy of the list tries to change it, they can't. Now, if you use objects that aren't immutable, so in other words, mutable objects, these are things you have to be a little bit more careful about. You have to watch out for two different threads touching the object at the same time. Even if the list itself is immutable, you can still follow those pointers and modify the object behind them. Now, these lists that we've been talking about so far, this one creates an immutable list. You can't just add things to it or remove things from it. You actually have to do list operations to create a whole new list, maybe removing some things, maybe adding things, whatever. If I said mutable list of, this, surprisingly enough, creates a mutable list, which is one that you can add, remove, set, things like that. Now, most of the time when you're dealing with a functional language, you don't want to have an immutable list. You usually want to have the mutable list because if you can set it up so that you have your functions be able to be parallelized using making them pure functions that we'll talk about later that don't have any side effects and don't work on mutable data, you're going to be a lot safer for when you set up your program to actually spin those off in parallel, doing various things, and then gathering the result at the end. This is the way that we try to take advantage of multiple processors. Up until fairly recently, Moore's law held pretty tightly, and we could rely on about every year and a half computing speed was double. We've really reached kind of the limits on where that law still applies. So they're really looking more at we make multiple processors available. And the more processors you have, the more things that can run actually in parallel. Excuse me. Okay, so any questions so far? So let's take a look at the mutable list down here. I'm going to say val list3 equals mutable list of, and I'm just going to say maybe like 1, 2, 3, something like that. Note that the val here, or the var here, has nothing to do with whether or not the list itself is mutable. The val and the var are only saying what this variable can be used for. So in this case, val list1 says that that's an immutable variable. So you're going to point it to something, or I should say property. You're pointing it to something, and you can never change where it points. Versus var list2, you're pointing it to this list, and you can change where it points. On this right-hand side here, we have list of versus mutable list. That's saying the data structure that we're creating, can you modify it? Up here, when we said list of, we can't modify the data structure. We're actually creating copies of it or modified versions of it, and then just pointing at it. Versus down here, I can actually say list3 dot remove at 1, and that'll remove the number 2 there. So if I came in here and I did a println of list3, and then after the remove, and let's go ahead and run that. You can see that we got the original list there, and then we removed the item at index 1. Note that in Kotlin, normally things start with an index of 0. You can modify that if you want to. There's some data structures that it may make more sense to have them be 1 based. Like if you're writing a matrix, for example, it might feel more natural to say the first element is 1. But Kotlin, just like in Java and C, they start them at 0. I think that's kind of an unfortunate side effect from C because they wanted to originally in C try to tighten up exactly how the code's working behind the scenes. And they're just actually using that index as an offset. So when the offset is 0, it's looking at whatever's at the beginning of the array that you're looking at. Whenever it's a number, then it multiplies that by, whenever it's non-zero, it multiplies it by the size of the thing you're pointing to. And that zero-based thing really throws people off at first. I mean, when they're first getting into programming. I mean, all of us are probably at a point now where it just feels natural because we used it for so many years. But in math, you really don't talk about index of 0. You talk about index of 1 as your first thing. So it just feels a little bit awkward just because they were trying to make something a wee bit more efficient in the compiler. Kind of unfortunate. If it were me designing that early on, I would have said index is 1. And if I want that side effect behind the scenes, the implementation detail, to be that that's actually an offset, I would just subtract 1 from it behind the scenes. So it's, we try to, when you're writing a compiler, try to hide some of the implementation detail from the programmer so that you don't end up with things that just feel awkward like that. And it's not that the -1 necessarily has to be something that's computed at runtime either. In a lot of cases, people will say bracket 0, bracket 1 bracket, and your compiler can optimize that away. Okay, so let's take a look at some of the things you can do with these. We're not going to talk too much about mutable lists. Most of the time, I'm going to try to steer you away from them toward using the immutable list. If you find that you're having some performance issues because of this, at that point, then you can look to optimize it and switch it to a mutable list under the covers. I'd recommend that you wrap it in some other type of class just to kind of hide that detail from anywhere else. But yeah, it's one of those things you can pre-optimize, and it will end up getting in your way later on if you try to parallelize things. So other things you can do with this while I'm down here, you can add items to it. That'll add an item at the end of the list. And then we can do a set, for example. Which, oh, actually set, there's the syntax for that. You can say list3 equals 42, something kind of like that. When we run this, we should see all those steps happening. So our original list, we removed that middle item, we added a 1 at the end, and we set the first element. The get syntax also works very similar to what your assignment did. And behind the scenes, they've implemented that using extension functions so that whenever I use the bracket syntax, it calls that extension function get on the list to fetch things for it. So pretty nifty stuff there. So this is the type of thing you can do with a mutable list. But it's really not the most interesting thing you can do with lists and other types of data structures like that. So let's talk about, let's see, did I want to cover anything else? I'm going to move that. I was going to talk about nested mutability. I'm going to talk about that later on. Just go into that in a little more detail because I really want to talk about when you do deep copies or when you are working with fairly nested data structures, what the difference is between having the object itself be mutable versus a reference to be mutable. So I'm going to go into more detail that another time. But in this class, I really want to get into some of the interesting things you can do with lists. And we'll also talk a little about maps a little bit later. Now we've already seen in the list that you created, let me say val list 5, that should be 4 really, equals list of 1, 2, 3, 4. And we've already seen a for each that you've implemented. There's almost the same implementation of it built into Kotlin. And when you call that, you can say println it, for example, and that should print out the 1, 2, 3, 4, just like you've seen. And if we take a look at the definition of him, he's going to look fairly similar to what you had to do. Now, yours was using a linked list. So instead of using a for, you had a while loop here. But this is what you might expect behind the scenes. It's like the list itself has a way to iterate across its elements, and then you're just calling that action that's passed in there. Now, a little note on here. Inline is a keyword that you can throw on a function that will just replace the for each call with the body of this. And in some cases, that's nice for optimization. Most of the time, it really doesn't make that much of a difference, if any. There are some places, though, where that can be useful to have different types of effects when you're calling your lambdas, and we'll talk about those another time. But that implementation should have looked kind of familiar. It's just that we're using a for loop here instead of your while loop behind the scenes. This guy you're going to use quite a bit. Keep in mind that for each is going to be whatever the type of the list is, unit is the lambda that goes in. So the lambda look kind of like that, which means you can't chain these things. So if you wanted to do several things with the list, and one of them was print things out, this guy is terminal. He has to be at the end of a dotted sequence of things. Instead, what we could do is use an on each. So if I said list for on each, this guy, the lambda, is going to be, you get your t in there. I'm sorry, that's not the lambda I'm thinking of. So for each, what did I just hit? Oh. Takes a list as the receiver. No value, oh come on fingers, no value returned. That's what I meant to say. Down here, this takes the list as the receiver, and then returns the list. So you can use this as in a chain. So I could say, and when I'm chaining, I usually like to kind of break them up like this. Boom, you're on each. And then you could do something else, like maybe we want to, let's try finding something. So that'll find the first thing whose value is less than 4 and return it. So this is a couple different types of things you can do. This chain, the on each, is pretty useful if you want to do some intermediate step. So you want to analyze all the data before you transform it or before you pull stuff out of it. Because once we've done this find, that again is another terminal operator. It's just going to return an object there. You can't chain it anymore. You can't keep doing list operations on it. So this is going to find the first element that matches the predicate. And the predicate is a lambda passed in there. Now there's also a find last, which will let you work backwards along the list. And I can do I'll just say find last works backwards. And it'll find the last element that matches something. Both of those can be pretty useful. Now some other interesting things you can do with this, the for each and the on each, sometimes you need to know where you are in the list. Maybe the item number you're looking at is important. An example of this is when I generate the course website. If we take a look at the, let's see, I think I had that up here somewhere. Actually, not for this course. Let me show you the site for. Oops. And I got to log in. Okay, I'll show you the one for the Android course. For the Android course, I have a generator that I wrote in Kotlin that generates an outline here. And you'll see here we have like week 1, week 2, week 3, module 1.1, module 1.2, module 1.3. And what I'm doing there is I'm keeping track of which number I am in inside that list. And in your assignment, you had to implement a contains feature that had a tell you if you found something or not. And hold on, I've got to turn the alarm off here. There we go. You'd implement a contains feature using that for each. And what you may have had to do there, what you had to do, was have a variable outside of that lambda. So we could do something kind of like a var n equals 1 if we wanted to know that first element, and then say list for dot for each, and then say println $n colon, and then the actual value $it, and then an n++. And that would let you keep track of where you are inside there. But this is such a common pattern, and people needed to do this quite a bit, that they actually created a function for this called for each indexed and on each indexed. And what that does is we can just say indexed. There's two parameters. We'll see an int and an int coming in. The first parameter is that index. The second parameter is the item. I'll just say value. And so now I can say index and value. Oops, I just said n. We'll just leave it as n. Now you can say n and value, and it'll just print that out. It's highlighting this n, by the way, because it's shadowing this var. Inside this lambda, n is this nested one, not the one outside here. Depending on how you're coding, it's generally, you want to try to avoid that. It kind of depends on your style for that. This particular one, I would say make it different, because especially since it's so close. Other cases, it may depend on how you're nesting things. I'll go ahead and change this. So we'll say index for that guy. So for each indexed and on each indexed as well, will give you this extra parameter so you know where you are. And that's really useful, because then you can print that out and do whatever you want with it. Okay. So far, so good. Any questions so far? Okay, I'm just trying to mark off over here which ones I've covered. Let's take a look, before I talk about map and all that stuff. Those tend to be a little confusing. So I'm just going to move those down farther. And let's talk about pulling parts of the list out, or maybe making sublists, things like that. So let's say that you want to grab the first 3 elements off of a list. Let's make this list a little longer. Let's say we only want to care about the first 3 elements. I could say list for dot take 3. That's going to grab just 3 elements. It's going to create a new list with the first 3 elements. Well, let's make it, let's change that a little bit. Let's say take 5, the first 5 elements. And then maybe I just want the last 2 elements of that new list. So if I said take last, grab the last 2 elements of that list. So if I started off with a list of numbers 1 to 10, what do you think I'd have at this point? What would be in the resulting list? 4, 5, yep, just 4 and 5. Because we started off, that take 5 grabbed 1, 2, 3, 4, 5. Then we're going to take the last 2 elements off of there. Now we can also drop pieces off. So if I said drop 1, that's going to drop the first, let's say create a new list without the first element. So at this point, I should be down to just having a 5 in my list. So if I do a little println on this, it's still going to be a list, but I should just have that 5. There we go. So we just have that list of the 5 at the end there. There's also an equivalent drop last. And these can be really super helpful. A lot of times if you're doing recursion, you're going to work with some portion of a list, and then you're going to pass the rest of the list into the recursive call. And now there is no rest or tail function. If you're used to a language like Lisp, for example, well, they have car and cutter, which is awful. But there's friendlier ones, first and rest, or first and tail, or head and tail. These are different ways you can refer to them. The head would be just the first element in the list. Tail would be everything after the first element. And those can be really useful functions, especially for recursion, because you process one part of the list and then recurse to process the rest. If you use those, you can quite often, if you're doing list processing, you can quite often make a tail recursive function, which is going to process the current element, and then the tail recursive call is just going to do the same thing on the rest of the list. That might look something kind of like this. So if I said fun print stuff, and I'll say that we have a list, which is going to be a list of, I'm just going to explicitly say integers. I don't want to talk about generics today. And then inside here, I could do something like if list is empty, return. I'm just going to say I'm done. Don't do anything else. Otherwise, I'm going to print list.first. And then I'm going to say print stuff on list.drop1, which is the equivalent of rest or tail in some other languages. If you've seen that. Now this particular function, because the very last thing that's happening is a tail recursive call, I can put tailrec on that. And what ends up happening here is it unrolls this into a loop, which means that we're not going to have the overhead of pushing things on the call stack. And we're not going to have the worry about, if it's a super huge list, potentially blowing up our stack. So this is kind of a useful way to look at taking a data structure and recursively breaking it down and handling something, making a recursive call for the rest. Okay, any questions so far? Oops. If tailrec rolls it up into a loop, is there benefit to using that over loops? It's a style thing. So if you get used to using a recursive way of thinking about problems, especially when you have a recursive data structure like a linked list, it's something that just it reads better to people who are used to the recursion. We could do a loop on this as well. You'll notice also that this is just using some kind of simple operations on this. We're not uh, having to do any type of data access. Now the big negative to this one is going to be that we're creating a new list every single time here, and that doesn't get optimized away. So this is going to be actually quite a bit more expensive. At the expense of feeling better for a recursive point of view. Now there are some places where this is actually pretty useful, because if you wanted to actually break up the list into smaller chunks and have something else process them, so let's say you're doing some kind of a quick sort and you want to break it up into sublists, process them in parallel, and then merge the result together at the end, this may be a better way to do that. Kind of all depends on what's going on with it. Yeah, there's trade-offs here, but this is a way that a lot of people, when they're doing functional programming, really like to think of things recursively. For this particular example, it's probably a lot easier looking at it just as a for loop, something like that, or for each. But you will see this quite a bit in some languages like Lisp. This is kind of the main way that people do things in Lisp to walk through lists. Okay, and Lisp is one of those languages. It's like if you ever, get into it, it's kind of a cool little language, but it's very hard to read if you're not used to it. It's kind of a funky looking language. We used to call it lots of idiotic, stupid parentheses. Okay, so we got these prints and everything like that. So there are a few things we can do. So I covered my take and drop. Now we can also do something that uses a condition to do these takes. So we could say list for dot take while, and this will look at this first however many elements that match this predicate and return that list. And so if I said something like it is less than 5, that will take the first n items that have the value less than 5. As soon as that predicate breaks, it stops. So the first time it finds something that doesn't match the predicate, it stops at that point. It'll only take that number of items. Let's see, so, and similar for drop while. That match the predicate. As soon as it finds something it doesn't like, boom, it's done with it. Okay, and I talked about first. There is an equivalent last. What did I talk about? Well, I did talk about first down here. So list for dot first. Be careful with list for dot with using first. If we take a look at him, he throws an exception if the list is empty. So if there is no first item, he'll throw exception. Instead, what's much better way to do this is to use first or null. Returns null if list empty. And when you use this in combination with Elvis, you can say, give me the first item in the list or some default value. So if there isn't anything found, boom. So we might say, or 42. Or well, maybe we use -1 as a marker for there's nothing there. So I can say val first item equals, and if there is no first item, boom, your value is -1. Okay, any questions? Okay, so next thing we'll talk about is doing some modifications on the list for reversing it. So if I said list for dot reversed, this returns a new list with items in the opposite order. That's a little expensive because you're creating a brand new list. There's actually a nicer way to deal with that, and that would be, actually, let me do that there, as reversed, which returns a view. Whoops, see if I can spell that correctly, of the list in opposite order. And depending on the type of list that you're dealing with, that can be really super efficient. If the list behind the scenes is an array, the as reversed for that array could just return a little shell of a list around it that modifies the get function. So the get function, instead of saying get 0 returning the first item, you'd behind the scenes subtract that 0 from the number of items in the list -1. And then that will be able to work from the back of the list up very, very efficiently just with a subtraction versus the first one where you have to create a new list and assign all those things inside of it. So if you ever need to reverse a list, as reversed is usually going to be your best bet. Now it depends on the type of list you're using. It won't always work for all types of lists, but for like if it's an array list behind the scenes, which is what list_of does, that'll work fantastically. Okay. Now sometimes you're only going to want to work on part of the list based on some condition. You're only going to want to look at the items that match a certain condition. So let's say that we wanted to deal with the odd numbers. Whoops. What did I do there? So if I wanted to go with the odd numbers, I could say list4 dot filter, and then inside here I have a predicate that says is something odd. So I could use it mod 2 equals 1, and that'll tell you it's an odd number. This will give you just the 13579 as opposed to all the items in the list. So println odd numbers. Let's go ahead and do that. There we go. Boom, 13579. That can be really, really super useful. And it's even more useful when you're using custom objects, where you can do filter is instance. Let's take a look at that. I'm going to create some types here. Let's first of all start off with a interface mammal. Well, I'll call it an abstract class. And then underneath that, I can have a class dog with a val name, string, and a class cat. And these are going to be mammals. And maybe a human. And maybe we'll go with a doctor who's subhuman. So now we've got our dog, cat, human, and doctor. But we'll make this one be human. Oops. Nope, that's not what I wanted. I wanted to add constructor parameters from human. There we go. And he needs to be open. Curse you, Kotlin, for that bad default of final. So inside here we have our dog, cat, human, and doctor. Let's go ahead and create a list of those. Val mammals equals list of. And then I will say dog, Fido, Fifi, and what's another dog name? Rex. Might as well be a clone name. And then maybe I have a cat in there. I use my first cat's name, Puffball. And let's have another cat here. The Thing. We actually called one of my cats The Thing when I was a kid. And let's have a human, Scott. And we'll have a doctor, the doctor. And that's probably good enough there. So we get kind of a mixed list of things. And what I'd like to do is just pull out the humans, for example. So I might say mammals.filter is instance. And I can pass in human right there. And then we can do things with it. We can say for each println human, and then $it. Now, in order for that $it to work, we have to make sure that there's a toString function on those. So probably don't want to use the $it itself. And let me mention something about toString. toString is really intended for debugging. It's not really intended for user output. The reason for that is if you think of a class that contains your data, you don't want to define the one true way to represent that to a user, because that's really going to depend on the user interface side of things. Whether you have a user interface that's using a GUI to present stuff graphically, whether you're using a command line interface, which is going to spit the data out, or whether you're presenting it as JSON to come back from a web service. It's really about how the front end wants to display it to the user or return it to the user. So inside of a class, toString is it's helpful just to see it when you're debugging, and so it's a good thing to have, but it shouldn't be used as the display mechanism for the user. So I'm going to come in here and say it.name instead of just printing it. And actually, let me change that to an on each. And then I can do another filter is instance for doctor down here. Something kind of like that. And there we go, that's good. And so this sequence should filter the list down to just the humans and the doctors because doctor is a subtype of human. And so we should see the doctor listed here as well as the human. Then it's going to filter it down further to be just the doctors, and we'll see the doctor printed out there. So if I run this guy, we'll see the human Scott, human the doctor, that's in that first part, and then it filters it down to just the doctor. Now, this is kind of contrived. You're probably not going to have code that looks like this, but you're going to very frequently use filter is instance to break down lists into certain types. It's very, very useful that way. And let me mark him. Mark him is covered. Okay. Any questions? When we talk about generics later on, we're going to see how this syntax works because it's actually super cool what they're doing behind the scenes. It takes a little bit to wrap your head around, but it's actually setting this guy up so it can remember that type and use it inside the function, which is something you can't do in Java. In Java, if you have generics, that generic gets erased and completely lost. With Kotlin, there's certain times you can preserve that and some very certain circumstances on how that works. So we'll see that out later on. And that's one of the things I really like. I really prefer this syntax versus if I had to do doctor : class, which is what it might look like in Java. And that would be kind of gross. Now, this one doesn't work in Kotlin, obviously, because it's giving you an error there. It intends you to use this syntax. And there we go. That all works good. Okay, let's take a look at some other things. Let's say you want to sort a list. So I'm going to, let's first of all start by making mammals comparable. And in order to do that, let me go ahead and put the name here, which is going to totally throw off. Well, no, it's abstract, so that should be fine. Okay, that's good. I'm going to have the actual comparisons be done at each level here. The comparable interface is one that actually comes from Java, and he just has a compare to function. And if we look at that function, we're going to see he returns an integer. If the integer is positive, so greater than 0, that means that the items are in the wrong order. Let me say that wrong. Yeah, that's right. If the current item compared to the second item, they're in the wrong order if he's positive. If it's negative, am I saying it the wrong way? Yeah, negative means that the current object is less than this guy. Positive means the current object is greater than. So in other words, you typically want to reverse it if it's positive. If it's 0, that should be the exact same thing as if the objects were equal. This function gives you a natural sorting order on things. So things like strings are comparable. We have a natural sorting order for them. If that makes sense to have a natural sorting order, you could implement something like this. So we could actually come in here and say compare to, put that function in there, and then we'll just say name compared to other.name, which actually isn't going to work because the other guy's a mammal. Here we want to actually have it be, oh, I'd have to get generics to make this work. Let's not do that for right now. I'm going to come back to that. Let's use the strings because the strings have a natural sorting order and they implement comparable. So we'll use the string list that I created up here. Let's make a longer string list. So we're on list 5. This is 5 now. Scott, Mary, Zach, Charlie, Claire, something like that. So we'll just have a list of names like that. And let's say that we wanted to see those sorted. So if I did list 5 dot for each println it.name. Let's do a little line separator here. Oh, let's do an on each there. That way I can keep going. So I'm going to start off just printing them out. And, oh, it's it because it's just strings we're dealing with. There we go. And then let's try sorting it. So if I say sorted, why is that not? Because list 5 should be a list of strings. What does on each return? That's really interesting that it works there, but not after the on each. I'm gonna have to break this up for this example. I'd have to look exactly how this is implemented here, but it sounds like there's a little bit of a generic thing. If we take a look at sorted here, you'll see that he takes a type, the item types are comparable themselves. On each just returns that iterable guy. That's interesting. No period before the sorted. There should be. Oh, I didn't have the period. Thank you. Thank you, Demas. That was, yeah, that was silly. This is what happens when you're not paying attention to your dots. So thank you for paying attention to the dots. So here, now that works. I was thinking there was some kind of weird generic thing happening there, but nope, nope, it is working as intended. So we're going to do the on each, so we're going to get that list returned, and we can do further things with it. Then I'm going to sort it. This returns a new list with items sorted. So again, that can be expensive. But do keep in mind, behind the scenes, they could actually create a wrapper for that. So if they know that the thing coming in is immutable, they could just go ahead and create a wrapper around it to represent the sort and just have the keys have a little mapping. Now for an array, it's actually cheaper to make a whole new array and hold on to them rather than just creating that mapping. But if there was some more complex data structure, it might be cheaper to keep a mapping inside. So if I do that and then print them again, we should see them sorted. And I'm going to put a little run in here to do, actually, let's say also, just to print out another little separator thing there. And what the also does is he takes something as a receiver and returns it. We're really ignoring it inside of here. So whether we use an also or an apply, either would work because it just takes the receiver in and returns it at the end and lets us do something in the middle here. So at this point, we're just going to say, I just want to run something. The reason run didn't work is because it was a unit. It's really a terminal operator. So I'm just using this to print out a little separator between the two. And let's see how that looks out. So we'll see that we had Scott, Mary, Zach, Charlie, and Claire, the original order. And the sorted order, Charlie, Claire, Mary, Scott, and Zach. Ta-da! That worked out pretty well. Now, if we want to do that with an object, any object that's comparable, you can use this. Only works for comparable items. If you want to do something with a list of things that are not comparable, so maybe you don't have access to change them, or it doesn't make sense to define a natural sorting order for them, you can do that. Let's actually add to mammals. Where did I define mammals? Up top. There we go. Let's actually add in. How do I want to do this? You know, I think I'm actually going to have to say val name string and val age int, something like that. And then each one of these is going to have to pass those through. So I'm going to say add constructor parameters, add constructor parameters, whoops, add constructor parameters, and then add constructor parameters. Why did that guy, something funky happened to that guy? Now he's okay. That's weird. Okay, so now we've got this set up so at the mammal level, we can ask any mammal for its name and its age. We can pass those up. Now we could have additional behaviors for these ones down behind the scenes, like make the dog bark and the cat meow and things like that. But really all we care about is the data for right now. So if we want to print those out and sort them, I could say list5 dot sorted by. And what this will allow us to do is pass in a predicate to say when one is higher than the other. So if I said A and B as our two items, oops, not list 5. Did I create a mammals is what the thing is. And, oh, actually, hold on. That is for comparables. So actually this is just returning you're returning a value that you want to use for that comparison. So if you're returning something that's comparable here, if you can do that, then this will allow you to pass in it.name, for example. So this is going to say for each mammal, pull out it.name and use that as the sorting key for it. And then I can print it out. And then if I wanted to sort it by age, I could do the same kind of thing. Let me go ahead and put my little also in there and do this guy there. Put him up there. Let's try that, see how that works. So this should allow us, oh, I didn't pass the ages in. So where am I creating these guys? Let's say he's 12, Puffball is 4, the Thing is 82. It's a really old cat. Fifi is 5, Scott is 55. The Doctor is, oh God, I have no idea. I'm going to say 999. And Rex is 2. So now if we run this, we should see that come up. Oh, I am printing it instead of the individual things like it.name. And let's, wait a second. Wrong it's. It's down here. So I sorted by it.name. Let's actually do a $it.name colon $it.age. And I need a closing quote there. And I'll do the same thing down there. That'll be a little bit more readable. Note that those kind of weird printouts were because we don't have a toString defined on those. And it just gives us, the only thing it gives us is the hash code with the class name in front of it. So now we'll see that up here, we're sorting by name, Fido, Fifi, Puffball, Rex, Scott, the Doctor, the Thing. And then down here, we're sorting by another piece of data, the age. Okay. So that gives you a lot of flexibility to do that. Now, if you want a custom comparator, which is an interface that has a compare to with two different objects, you can do a sorted with. Not going to get into that. It's in Kotlin, you're probably not going to use it as much. There's some other things you can do with, there's, I think, an alternative sorted by. Where's the one that takes, there was one that takes a list of properties. Takes a var of properties. I'll have to look it up. There was one where you could pass in a sequence of things to sort by, and I'm completely blanking on it right now. So let's get these guys out of there. Now let's say that you want to do something with chunks of a list at a time. So you want to say, let's take a look at each 3 items and do something interesting with those 3 items. So I could say, which one had my list of numbers? list 4. So I could say list 4 dot chunked into chunks of 3. And that'll be the maximum size. So in this case, we'll actually get 4 sublists out of this. This will set it up so that if I end up doing a for each, notice what the type is here. The type that comes in is a list of integers. So it's breaking down my list into multiple sublists. And then I could do things with them. So maybe I want to just say println it, just to print out each of those sublists. Let's see how that looks. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Kind of neat. Now, if instead we want to take a look at a little window of items, let's say we want to pretend that we're going to look at 3 items in a row, starting with the first, then starting with the second, then starting with the third, and so on. We can do windowed 3, and then as we print this out, we're going to see 1, 2, 3, 2, 3, 4, 3, 4, 5, and so on. So it's kind of a little sliding window along the way. And there's some algorithms where that's really useful to have. Okay, let's come back here. Now, if we want to do some math with these lists, I could say println list 4 dot sum. Now, in this case, the sum will only work against things that are integers in this case. I think it'll work for other types of numbers. There's overloads for it. But this will just give you the sum of all the items in the list. You could also say average, min. Isn't min one that works? I guess min and max are not defined. I thought they were. We can do min of, which seems a little heavy, and max of. I'm kind of surprised they didn't define one. I thought they had. But these will print your sum, average, min, and max. If, however, you have custom objects, this won't work. So if I came in here and tried to say mammals, if I could spell mammals, we'll notice that sum is not defined. This is a case where we want to say sum of. And if I said it.age there, it's going to look at the age of each item and add them together to give you the sum of all those ages. So you can do some interesting math things with these. And the more you get used to all these different operations and combining them, you can make a very readable sequence declaring what you want to do with the list. If you think about what would happen if you wanted to write loops to do this type of stuff, this would be a pretty thick block of just lines to do things. Sort a list, then have a loop, then print out something, then sort a list again, then print something. It doesn't read as nicely as this. This is really a set of instructions on what you want to do. And this type of a style is a very functional style, a very declarative style. So you're basically screaming at the user, here's what I'm doing with my list. And I find this very, very readable once you get used to it. And also once you get used to it, the code can shorten up quite a bit. Oh, just a little note. I sent an announcement. Please go ahead and upgrade your Kotlin plugin. It should prompt you when you start up IntelliJ. I'm going to hit install. I'm not going to bother restarting it because it's going to ask you to restart to finish that. But update that and then restart it. And there's some bug fixes they put in there. I can't remember if there's any new features in that particular version. It still works against Kotlin 1.6.10, which is what we're using, but it's an updated plugin. Okay, questions on anything so far? Okay, let's see, and I did find. Now, sometimes you want to say, tell me if everything in the list satisfies a certain predicate, or if anything in the list satisfies a predicate. And so you can do things like println mammals any, it.age is greater than 30. So this predicate is going to tell me, is there anything in the list whose age is greater than 30, which should return true because I'm in there. Now, if I said all for that, that's going to say only return true if everything in the list satisfies that. And I'm trying to remember if there was a none. There is a none. And none says, if that's satisfied for even one, I'm done, I'm false. It's kind of like, it's basically the opposite of all. I mean, everything fits it, at least one thing fits it, and nobody fits it. The all always has to cycle through, well, if it's true, it has to cycle through everything. Any, if it's false, it has to cycle through everything. Any will drop out as soon as it finds something. All will drop out as soon as it finds something that doesn't match it. And similar for none, it'll drop out as soon as it finds anything that matches it. These can be really, really useful just to check things along the way. Okay, questions? Now we're going to get into the stuff that tends to cause a little bit of confusion. Let's say that we're looking at this chunked or windowed or something like that. Notice that we've broken it down now such that the result is a list of lists. And we're cycling through that list of lists. Each item is a list there. Maybe we want to flatten that back out into a single list. So we take all of those separate lists of lists and just make it a normal list again. Let's take this guy down here. And I'm going to say, let's chunk it. I'm going to do a also println and we'll do this with some equals there. Whoops, shoot. And he's happy now. So we're going to chunk it. We're going to see what it looks like. Note that the also is telling us the type. It's a list of lists at this point. When we do an on each, each of the items it's looking at is an individual list. So we're going to look at that. But let's say I want to flatten it back out. I can say flatten. And then when I do these guys, notice how also is just a list at this point. So the flatten converted it back into a list by taking the items out of the first element and using those as items in the base list, the items out of the second element, items out of the third element. And so we should end up bringing them all back together again. Let's see how that looks. So, whoops, did I not print it to start with? Oh, I didn't need that there. There wasn't anything to print back there. So I started off, I broke it into these separate lists. So I have a list of lists and I'm printing those items. And then when I flatten it, it's back into a normal list again. And that can be super useful because sometimes you'll call some functions that'll generate lists for each individual item. Like let's say that I started off with a little function down here. And I say, generate numbers. And starting with n int. And let's say what I want to do is create a list of numbers out of that. I'm going to do this using a mutable list for right now, but I'm going to show you another thing we can do with it in a moment. So we'll start off by saying val list equals mutable list of, and well, we'll just do this kind of brute force here, a little bit blunt instrument. We'll say n plus 1, n plus 2. So we're just going to generate a little sequence based on that. So maybe what we want to do is at each step along the way, generate some sublists. Now I could do this pretty straightforward with a declaration. but it's again, it's kind of brute force. I could say list 6 equals list of, and then generate numbers starting with 1, 10, 20, 30, something like that. And, oh, it wasn't returning anything there. It was just a unit. So now we have this list 6. If I end up printing this out, I should see a list of lists coming out. So we have a list with little sublists in there, 1, 2, 3, 10, 11, 12, 20, 21, 22, 30, 31, 32. Okay, so far so good. Now it doesn't feel quite as nice as some of the other things. I was kind of explicit in how this is, and maybe I wanted to vary this range. Maybe I have it not just be a starting point, but maybe an ending point as well, which could make these sublists vary. That becomes a little problem here because then there's no way for me to use this mutable list. I'm actually going to have to create a mutable list, set up a loop, loop through it all, add all those items in, and that's kind of gross. So instead, what I'm going to do is introduce another operator called map. And what map does is I can say list4.map. Map is going to create a new list by taking each item in this list and transforming it using this function. So in this particular case, list4 was my list of numbers, right? I believe it was. Yes. And so maybe what I want to do is for each one of those numbers, I want to generate the number starting with. So let's try that to start with. So generate number starting with it. So whatever the item was in the list, we're going to make a new sublist starting with that number. And then my overall result for the mapped list is going to be a list of those lists. So now if I print that out, what we're going to see is that for the first one, we create 1, 2, 3. The 2, we create 2, 3, 4. The 3, we create 3, 4, 5. The 4, we create 4, 5, 6, and so on. So we've created all these different sublists. Now, what do you think is going to happen if I flatten this list? Any ideas? What might the first 5 numbers look like? Nope, duplicates don't get removed. It's a good question, though. And there is a way to do that. 1, 2, 3, 2, 3, exactly. So it's like all of these numbers, basically we're just going to remove all these brackets in the highlighted part that I've put in here. It just flattens it out. So now it's not a list of lists anymore. It's a list of just the values from all those lists. Now this type of operation, this combination where we map something, and then let me put a flatten in here. So you can see what that flatten does. We'll see that we have our 1, 2, 3, 2, 3, 4, 3, 4, 5, and so on. That combination can be pretty useful, especially if you have a deeply nested recursive algorithm where you're going down, building little sublists, and then you want to join those lists back together. The flatten does that joining for you. Because a lot of times you're going to see a map and a flatten happen together, they actually have an operation called flat map. And so I can come down here and say flat mapped list4 and do something kind of like that. And if we take a look at this, whoops, we should see the same thing as that result right there. So the flat map just does the combination of mapping. Keep in mind that's just a transformation creating a new list from each item into this other list of things. Now let's see how you might use this flatten operation or the mapping operation in there. Let's say that we have this list of mammals that we have, and we want to get all their names and just their names. So we just want a list of names. What we can do is say mammal names equals mammals.map it.name, just like that. And this is going to take each of the mammals and create an item for each mammal that's just its name. So this new list, mammal names, if I float over, it's going to be a list of strings because it's just those names we're dealing with. I could also have mammal ages by doing something like that. So if we had a task to find out the average age of all our mammals, we could represent that by saying mammals.map it.age.average. And again, I still like to split these up into separate lines so you see each of the separate steps on a separate line. So what we've done is taken our list of mammals, converted it into a list of just the ages, and then grab the average of those. Now for this particular example, I believe we can just say mammals dot average. Oh no, they don't have an average of. I thought they had an average of. So you wouldn't be able to do that. I was thinking if they had an average of, you could pass in the thing you want to average, but nope, did not have it. That would actually be a useful one. I'm not sure why they don't have that. But we take our list, convert it into just the stuff we want to look at, and then average it. Now again, we could also come in here and say, I want to filter instance human, or maybe I just want the cat ages. We'll put the cat in there. So now we're just going to get the average age of cats. And this one, I'll get rid of that there. Just by adding that step in there. And it reads pretty well. It does the job for us pretty nicely. Any questions so far? And this style of programming, it can take a little bit to get used to. But once you're used to it, it really feels good. I've been really happy with it. And I think it reads pretty well, just from somebody reading it, even if they're not super, if they're not super into functional programming. You look at it and you're like, okay, I got a sequence of things happening here. Makes some sense. Okay, any questions? Now, sometimes what you want to do is get a single result out. It might not be an average. Maybe what we want to do is, oh, and let's say let's go ahead and do a sum, but not use the sum by. There's other things that we might want to join. I'm just trying to think of a good example right now. Boy, I just used it the other day. I'm trying to remember what it was. Oh, I'm blanking. It'll come back to me a little later. But let's say that we want to take each number and kind of accumulate them into something. So let's take a running sum. We want to sum up things. What we can do is we can say mammals.map it.age and then .reduce, passing in an accumulator and a value. And you remember when we talked about recursive functions, I talked about the concept of an accumulator. So we're keeping track of the value so far that's being built up. What reduce does is the very first time through, it's going to pass in the first item and the second item. And you're going to do something with those two there and return a value that'll be used as the next accumulator. So the first time through, it's the first item, second item, do something with it, then pass in that result and the third item, do something, pass in the result and the fourth item, do something, pass in the result and the fifth item, and so on. So in this case, I could just say accumulator plus value, kind of like that. And what this should do is this should give us the sum of all the items in the list, or in this case, all the ages of the animals. So let's do a println of sum of it.age, which this is actually normally how I'd write this because it's super nice and short. Sometimes people put some parentheses in, or some spaces in there. And then this is just the more explicit. I'm going to walk through and merge the values together. We should get the same result for both of those. There we go, 1159, 1159. I'm glad I didn't try to manually add those up because I would have had to think about it for a moment. Short moment, but I would have had to think about it. Okay, so what this does is explicitly says, take this list, get the stuff I want to work with, take those items piecewise, so one at a time, and merge them all together. Now this is always going to take two items and do something with them. If you want to, you can actually use a separate function called fold, which you explicitly give the initial value of the accumulator. So if I come in here and say fold 0, we're going to get that accumulator which starts off at 0, and then we add the value. So it looks fairly similar. The difference here is this will actually work on a list that only has one item in it. This one you have to have at least two items, and I can't remember, does it throw an exception or does it just not do anything? Throws an exception if the collection is empty. So what does it do? Huh. Oh, okay, so what he's doing here is he starts off with the accumulator being the first item, and if there's no other items, he's just going to go ahead and return that first item. Otherwise, he's going to perform the operations piecemeal, so it doesn't have to have at least two. Now fold, let's come back to him, accumulates with starting with the initial. So we start off with the initial, and if there's no items, you always get that value back. So the fold won't crash. It won't throw exceptions if there's no items in the list. It'll just return that initial value to start with. So this one's generally a little safer to use. A lot of times you'll hear about map reduce being used together. For fold, can the accumulator be another data structure, say an empty array based on that initial value? In either case, they can actually the full of the accumulator. Yeah, actually, that's what the example I did was something really similar to that, where I had an object that I was filling data in, and I mean we could use a list for example, but that's boy, I wish I could remember what I did because I had a really good use for it, where the fold took in an object and the accumulated values kept putting things in there. Oh, so let's say for example you wanted to go ahead and do the yeah, I could see that being used in JSON. I think the thing that I was doing at one point was grabbing the min, the max, and the sum all at the same time. So we could do that if we had something kind of like a data class. Um, eh, what's stats? How about that? And in there, I'm going to have a var min, which is going to be passed in, and then a var max, which is passed in, and then well, I need to start it somewhere. So our min, I'm going to be int dot max value by default. Max is going to be int dot min value by default. And then sum will be 0. And that should be good there. So what we could do with using the fold here is start off by saying I have a new stats. That's going to be my accumulator coming in there. And then what I'm going to do is say stats.max equals max of stats.max, oops, and value. Do the same kind of thing for the min. And then the sum plus equals value. And and then return the stats. So we could do something kind of like that. And these guys need to import. There. So that's one thing we could do. Or if we wanted to shorten this up just a little bit, I could say stats.apply. Something kind of like that. And this would be a good use of apply here. What it's doing is it says, take that existing stats object, and I'm going to do some stuff with it, and then just return that object. This has a couple benefits. One, I don't need the explicit return statement because the last expression in here is what's getting returned, or I don't need to explicitly just say stats at the end. And then inside here, it lets me shorten it up because stats is passed in as this. So I can say max equals blah, 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 and all that. And then, well, actually, if I print that, the resulting thing that comes out is the accumulator. So I should print that guy out who's a data class. So let's see how that one works. There we go. So min is 2, max is 999, sum is 1159. So exactly what we expected it to be. So this is something that you can do a little bit more efficiently. You can actually grab all those values together, process them all at once, as opposed to having to cycle through the list multiple times. I really wish I could think of the other one because I had a really nice example a couple weeks ago, and I'm just blanking on it. Generally, I prefer using fold over reduce. You just have a little bit more control with fold. But this, thank you for bringing it up, Eric, because this is a really good way to use an accumulator object that isn't the same value. It's just something that pulls stuff together. There are plenty of places like this where you'll suddenly realize, oh, I'm just gathering a bunch of stuff together, or I'm processing a bunch of stuff. This is actually a really good example for that. So thank you for bringing that up. Questions on this so far? Map isn't exactly the nicest name for this. It's a name that's been around for a while. Usually map and reduce go together quite a bit. I kind of would have preferred transform. My fingers prefer map because I have to type it a lot, and I don't type in as many letters that way. So it's a very useful function to have. Okay, so I covered any and all, map, reduce, and fold. And let's take a look at grouping by. So let's say we want to be able to look the mammals up by name. Now, one thing we could do is we could say mammals.find name equals Scott. And then if I print that, .age, oops, let's try 2 equal signs there. And oops, it.name. Now I'm awake. Find or null. Oh, I'm sorry. It's first or null. Find returns null if it's not found. I wish they were a little more consistent. They tried to clean that up over time, but find didn't throw an exception to start with. It always returned a null, whereas first throws an exception if there's no item in the list. I would have preferred it to be really explicit, like find or null, just so you're really screaming out what's happening there. So this is one way I could say, find the mammal whose name is Scott and return the age. So if I do this, I should see 55 come up. There we go. I'm sure I don't sound 55, but I am. So this is one way we could do that. But think about what this is doing. It's going to walk through the entire list, testing that every single time. If we have a really super big set of data, that could be pretty expensive. So a lot of times what I want to do is set things up so that you can search for them using a hash table. And we can do that by using grouping by. I can say mammals dot group by it.name. And this is going to be mammals by name. And if we float over this guy, we're going to see that he's a map of string to list of mammal. So if mammals have the same name, there'd be a bunch of them in there, there'd be multiple of them in there. You have to be a little careful about this. If you know that it's going to be something unique, you wouldn't want to use group by, you could use something else. Actually, let me change that to associate by, because that should be a one-to-one. I think that's really what I wanted here. Yes. So this one is associate by is going to work if there's exactly one by each name. So if the names are all unique in this case. If the names aren't unique, I believe this is going to overwrite. Two elements the same key, the last one gets added. So they end up overwriting. Whichever one actually gets the last one wins there. This is useful if you actually have something that's actually a proper key for something, so that you know it's going to be unique. Name isn't necessarily going to be unique, but in this case, let's assume it's unique. So mammals by name using associate by is going to create this map of a one-to-one relationship between the name of the mammal and the mammal. And once you have that, you only need to do that once. You could use it later on as many times as you want. I could say mammals by name sub Scott dot age. And note that this might not find something. So the little red under here is telling you that that could be null. So again, I could do this with my friend Elvis. And we should see that 55 being printed out again. This is much, much more efficient. The hash table lookup is pretty fast. It's a log n operation as opposed to an order n. When you're doing the walk through here, your worst case is you're walking through the entire list. Your best case is you find it on the first shot. If it's not found at all, you have to walk the entire list every single time. This guy, he's going to look up using that hash code that we talked about to see which bucket he falls into the map, and then go to that bucket and see if it can find the matching one. In this case, it's a one-to-one relation between the keys and the buckets. So there's only one thing to look at that point. So it's a very efficient operation for that lookup. Now, if we had several things that we wanted to group by, so a good example for grouping here would be the types of these guys. So if I said val mammals by type, I could say take my mammals, and this is where I want to use the group by, it : class. It : class is metadata describing the type of something. And so what this is going to do, if we come over here, it's going to create a map from k-type or k-class to list of mammal. So the key is going to be the type of the mammal. The actual result coming back is the list. And so now what I could do with this is do a print mammals by type sub cat class, or dog class, or human class, or doctor class. And this allows me to look it up. I've done some pre-work on this. And when you're dealing with functional programs like this, if you know that you're going to be using the same type of lookup multiple times, doing an intermediate step like this to create indexed data can be really helpful, especially if you need to look it up quite a bit. It does take a moment to get there, but it's better than doing that lookup multiple times. Whoops. I'm going to come up here because I'm getting tired of that. And I'm going to define, by hitting Alt Insert, the toString function. Hello. With the name and the age. And now when we run it, we'll actually be able to see those come up. So this is good for debug, but this isn't something that you'd want to use in an actual interface. Because these are pretty ugly, right? Mammal, name, puffball, age 4. Not exactly what you'd want to use for a user interface. But we can see here that all these guys are being printed out. Now, unfortunately, it's printing out mammal. Let's think about this for a minute. Up here, we're explicitly saying the type is mammal, and that's not really the case. What we'd like to do is print out the real type of these guys. So instead of saying mammal there, I'm going to say $this : class dot simple name. And that should give me the actual class name, just the simplified version, not the qualified version. I'll show you what that qualified one looks in a minute. But if I run this, boom, now we can see there's just cats up here, there's just dogs here, there's just a human here, and just a doctor there. Note that this one is only humans, because when I do that group by, it's using the explicit class. It's not using the class hierarchy to do things, to do that grouping. Now if I change this to qualified name, I should see week 501 dot in front of each of these. So we get the fully qualified name of each type. I generally don't do that in a toString. You can if you want to. If you need to be able to look these things up, if we have the same class in multiple packages, same class name in multiple packages, that might be useful. You really should try not to have the same class name in multiple packages because that can be super confusing. But it's going to happen sometimes. I just prefer simple name there. Now another little trick, just as a by the way, if you weren't able to get the class metadata, and some languages won't let you do that, instead what you could do is define a little function here, or a property. Let's make it a val. I'll say type name, which is a string. And then up here, I can just say type name. And he's happy. So now we're going to implement these, not as constructor parameters. Dog. And why is he not happy? There, now he's happy. He's just slow, that's all. And then we'll just change these. Doctor, human, cat. And if I run this, I should see the same results. So what I'm using here is polymorphism. And I'm doing that by, in the superclass, defining a property or functions. In this case, it basically is giving me a get type name function. And then I'm overriding it down here. So at compile time, it knows that there's a type name inside mammal. And that's what I'm actually using down here. Well, I'm using it from the toString up here, this type name here. So all he knows about type name here is it's a mammal. But then so he resolves that to be a string type name property. Then at runtime, we look at the actual types when this toString is being run, and it calls the appropriate type name in the subclasses. So that's where we're getting that benefit of polymorphism hitting us here. Okay, so that's grouping by. I think that's about all I wanted to. Oh, I still haven't talked about maps. Let me talk about maps briefly, then we'll take a little break. So far we've seen this list and mutable list of. You can do the same kind of things with maps. So, why don't I just start up a new file? We'll start a little clean here. I can say val people, and let's create a data class person name string age int. There we go. And I could say val people equals, we're going to first of all create a list of them. Whoops. And then we're going to call to map on it to actually create a map. And the items we have inside here are going to be pairs that we create. So I'm going to say Scott to person Scott, Mike to person Mike, Claire to person Claire, and let's say she's 25 and Mike is 15 and Scott is 55. So what we're doing, this to function, and that actually is a function, is creating a pair object. And if I have a list of pairs, I can call to map on it to actually create a map out of it. And that's kind of cool. But we'll notice some duplication here. Scott, Scott, Mike, Mike, Claire, Claire. That's kind of gross. So what might be a better way to approach this? Any ideas? Any thoughts? How can we use some of the stuff we've learned already to make this a little simpler and remove that duplication? Any thoughts? Any guesses? Wild inklings? A scoping function. Not quite. We wouldn't be using a scoping function for this one, but something that we talked about today already. So a lot of times when you want to create a map of things, a lot of times you're taking some kind of key value out of an object and then creating this pair out of it. So if instead we started off with just a list of people, and so we'll get rid of these pairs to start with. So that gets rid of a lot of duplication there. That's great. Notice how the to map isn't working anymore because that only works against a list of pairs. So what we need to do is translate that from a list of people into a list of pairs. And how can I do that? How can we translate the values of one list into a new list of different values? We can use the map function. And so the map function takes each of these values, each of these persons, and then it's going to create something new. It can either pull a value out, like we already saw it saying it.age, for example, to make a list of just those ages. But we could also use that to create new objects. So we could say it.name to it, which is exactly the same thing we did explicitly up here. But now we're just looping through creating all of those individual pieces there. Once we have that, we can then create that map by calling to map on it. Does that make sense? Now if I come down here, we'll notice that map has a little squiggly on it. It says call chain on collection type can be simplified. So we can actually call associate by like we did earlier on. So I'm going to hit Alt Enter on that and say merge call chain to associate by. And it's going to say associate by it.name. So that's going to create a map again using the name as the key, just to map those guys up. So it's the same thing as doing this. So this will give us a map. If we look at the type of him, the map is going to be from string to person. So if we use a name, we can find the person. So we can do things like people 3 sub Scott question mark dot age. and then Elvis -1, the same kind of thing we did before to look up somebody's name or age. Make sense? Any questions on that? Now, if you have a map, quite often you want to walk through the values that are inside of it. So if you do that, you could say people3 dot values, just to get the values that are in there, dot for each, and do something with it. We'll just say println it dot name. So that'll just grab the values that are inside there. I could also do the same kind of thing with the keys. Note that the keys are strings. So if I float over it over here, I'll see that it's just a string. So I can just print out the keys that are inside there. But what if I want to work with both at the same time? If I say people for each, it's going to return an entry object. So we'll see it says map.entry there, which has the key and the value inside of it. And if we do this, what I like to do is destructure that. So I can say key and value using that destructuring declaration there. And then down here, I could print out $key, $value if I wanted to do something kind of like that. Now, I think if we try to do this without the parens, I think that's in a later version of Java is what it's going to complain about. Replace with Kotlin's for each. Yeah. The problem with the for each like this is actually taking advantage of Java's for each, which returns the key and the value. But that's for a specific Java version or later, and I think it's 11 or 12. I can't remember. So it's generally safer to use Kotlin's one with the destructuring declaration there. So it's going to return that entry and then break it up. Because that entry, if we take a look at the map.entry, can I see that? Let's see. So I want a, why am I blanking on the name of the component one? And let's try map.entry.component1. Huh, that's not finding it. Let's see if I can do it this way. Let's say, see where he's defined. There he is. So we'll see that in this maps file, they've defined some extension functions on map.entry. So map.entry is the type, that's the receiver for this, and we're defining a component 1 and a component 2, where component 1 returns the key, component 2 returns the value. And because we have these component 1 and component 2 functions, we can use this in a destructuring declaration, and that gives you that key comma value. So when I do key comma value, it's going to call component 1 and assign key to it. It's going to call component 2 and assign value to it. So these are a couple different ways you can walk through the items inside of a map. Now you can also map those items into other items by using mapping functions. A map is a collection like anything else. But these are just a couple kind of specific things you can do to work with the keys or the values or both at the same time. Okay, any questions on that? And maps can be really useful data structures. There are some alternative maps where you can have a sorted map or a tree map. A tree map keeps track of things based on a comparator or their natural sorting order. And what was the other kind of map? I am blanking on the one. There's one that keeps track of them in order of insertion, so that if you did a for each, the order is deterministic. In this case, when you say keys for each or values for each, it doesn't have any type of what's the word I'm looking for? Defined sort order or defined initial order for it. Um, so depending on the order that things got inserted, it might come out in a different order. You can't really depend on it. So if you really want to depend on the order, you're going to want to apply some kind of sort to those. Okay, so does Kotlin have something like Python's default dict? What is that in general? Can you describe that really briefly? Because I do not know Python, unfortunately. I suppose I could look it up. You can declare the default data type like it's a list rather than an exception. It'll give you an empty list if the key doesn't exist. Um, I'm trying to think if you could probably override the get to do that, or I think there's a getter default. Let me take a look. If I said people 3 get or default, yeah. So get or default is one thing you could do here, and say that, and pass in a default value for it. Like if I had a val dummy person equals person dummy, which is really, this is not how I would do this. We'll do and talk about after the break how I would really do this. And then pass in dummy person. That's one way to do it. There is it an alternate version to getter default? Let me check here. That takes a lambda. No, there's, yes, get or else is what I'm thinking of. So get or else allows you to have a lambda as the other argument. And this is useful if it's going to be expensive potentially to create the dummy value. If it's always the same dummy value, you can use get or default, and that works fine. And is this something that's in Kotlin? Get or else is a Kotlin guy only. Yeah. Um, there's a Java one that I think is like get or produce or something like that, or produce if not there. Um, this will allow you to actually create an object if it doesn't exist. Okay. Is that kind of what you're looking for? Now there might be, just to try this for the heck of it, if I say class my map, um, I'll just call it my map. Why not? It's going to be a map. Well, ignore the generics for a second here. Just have some key and some value inside there. By, what do I want to do? Mutable map of. And I'm going to explain this by a little later, so I'm just going to kind of wave my hand and say pretend that didn't exist. So I'm basically creating a map that uses this as how it stores its data. And inside here, if I override the get, and then maybe I have a default value, something like that. And instead of returning that v, I can say we're going to return get key Elvis v, and I think that'll work. Oh, otherwise default value. So what this allows us to do is we have I'm going to make him private. We're defining a map type here that you have to explicitly pass in that default value. So I came in here and said my map equals my map of string person, and we're going to pass in dummy person as the default. And then I'm always going to get a non-null value coming back. So if I did a my map sub Scott, I can always say .age. I don't have to use the null safe operator there because I know the value coming back is going to be non-null. So I don't know if this is a little closer, but this is something you could do. And I will be explaining this, I don't know if it's next week or the week after. Well, the week after would be the midterm. I think. Yeah, that's right. But I'll be explaining this fairly soon. This is a delegation type thing, and it's super, super cool. Mainly because I did a annotation processor for Java a while ago that actually did something very similar to this. And I thought it was really cool then, and it's like now I can do this for real in the language instead of having to do a separate processor for it. But this gives you a way to have a default value. And so the client doing these get or else or get a default doesn't have to know the default. It's only when you set it up you have the default. Or you could even have it just hardwired inside here what the default is, if that makes sense. Okay, hopefully that helps. Any questions? My map is awesome. Thanks for going over it. Yes, my map is totally awesome. Wait till you see some of the stuff we're going to do later. It's going to blow your mind. Delegation is so cool in Kotlin. There's just, what can I say? There's a lot of cool stuff in this language. It's great to be excited about a language again. Okay, let's take a little break. It is 9:16. Let's start back up at 9:26. Put it back up. Any questions before we continue on here? So one thing I mentioned here is that this dummy person is not the way I would do things. But let me first of all explain what this dummy person is. There's a design pattern called the null object pattern. And the idea here is instead of using nulls to represent that something isn't set, we use an object that we can just check to see, is it a dummy object? And this object has some reasonable default values. So you could just go ahead and use it in a chain and not have exceptions thrown and not have to explicitly check for null all over the place. Pardon me one sec. Sorry, I had some coughing there. What we would do is instead of having that null, you create a dummy instance that you call the null object for it. So if we had a data class person here with, once again, val name, wow, fingers, and then val age. I was doing so well that first half of the class, and now my fingers are just like not cooperating. If we wanted to define a dummy instance of the person, we would just go ahead and define a variable for it. So I could say val, I'll call it null person, equals person with an empty name and an empty age. And really all we're doing here is holding on to a value. So null person is always pointing to a person. So we can actually check to see if the resulting person is null person, do something with it. Oh, I know what I didn't talk about. Hold on a second. I'm just going to make a note here. We'll come back to that a little bit later. So this gives me something to test against, but now I can make sure that I never return a null on something. So I could have a fun lookup person passing in a name and have it always return a person. And inside here, I'm just going to, for now, say return null person. And now when we're using this, we can just say lookup person Scott dot age, and that won't blow up. So there's a big advantage to that. Now in this particular example, this one isn't super useful because you're going to get bad data coming back. But if that's the case, I could then say when val person equals lookup person, null person, can report person not found. Something kind of like that. Otherwise, we can do something with the person. And the advantage you get here is that you don't have any null pointer exceptions out of it, but if you're not careful, you could end up with garbage data. So there's some trade-offs on that. This is most useful if you're doing things like, let's say you're looking up a list of stuff and the default is an empty list. So if you ever had let's do first of all, val empty list equals empty list of string. This creates a dummy list for us. And I'm just holding on to a single instance so I don't recreate that over and over. Actually, I can't remember if this actually, he does. Okay, good. So he actually is using a single version. But if we called it multiple times, depending on what's going on behind the scenes, maybe some implementation creates a brand new empty list every time. In this case, they're actually using something I'm going to talk about in a minute. But if we have this empty list like this, and then have a fun lookup people named name string, and that's going to return a list of person. So I want to make this list of person. Then if this guy could find the people, he creates that list. Otherwise, he returns that empty list. And then down here, I could say when val people, or actually I don't even need the when here. I could say lookup people named Scott, and then do a for each. And if there aren't anybody, no harm, no foul. I've got an empty list. The for each doesn't do anything. There's nothing to iterate over. So an empty list is a really good example of a useful, so very useful null object is an empty list. And this is something that you'll do quite a bit. If something returns an empty list versus if something returns an actual valid list is a lot better than saying return a list of things or null to say that there isn't anything. That empty list is super, super useful because you can just chain it like this and everything just works beautifully. Okay. So in Kotlin, there's a slightly better way to do things like this. We can declare something as an object. And what object means is that there is a single instance of this. And typically you use the same naming convention for classes for objects. So I would say empty list like this equals empty list of person. Maybe empty person list, something like that. And whoops. Oh, silly me. So we will say list. Oh, shoot. How do I want to do this one? I think this is how I have to do it. There we go. So what we're doing is we're saying this essentially is a singleton. It's an instance of a singleton class. So we're creating a class definition for empty person or empty person list that has exactly one instance, and this is the instance. Object means it's an instance as opposed to a definition of a class type. And you can actually have explicit functions inside here if you want to, but a lot of the times you're going to use it like this, where you're just going to say I have an object, and maybe its representation is something else, just an empty list there. So all I'm doing is having this singleton. I can use that to do something like this when up here. So I could say when val people equals look up people named Scott. And then I could say if it's an empty person list, if I wanted to do something explicit when it's an empty person list, I could do that. Else, I do something else. This is nice because I don't have to keep creating new instances of stuff, and I get a superclass here for me. And this actually is an explicit type, as opposed to up here where this is just a value. So it's not like we're creating a subtype for it. The thing that I like to use this the most for is combining it with sealed classes or sealed interfaces. So what I want to talk about for a moment here is, let's come into here. So the first thing to remember, where I have a sealed class, only subclasses, let's write it the right way here. Subclasses can only be defined in this module. And by module, we mean basically the jar that we're creating. For this week 5, all of this code is going into the same module. So it's not anything about a package or anything. I personally kind of wish that it had been limited to packages. I think that would have been slightly more useful. But it's basically the compilation unit we're creating. We're compiling all this stuff together and creating a jar. That makes it really super useful for defining a library. So in this library, you only have a fixed set of subclasses. And because you have a fixed set of subclasses, you can have an exhaustive when expression on it, which can be super, super useful. It's kind of like an enum on steroids. So sealed class or interface. So a good example of this, and where you're going to see it used quite a bit, is in a response or a result class. So if you have an API you're calling, and you want to have some indication of what's going on with the value. Hey, I'm fetching the value. Here's the value I got. Or oops, there was an error. Or oops, it timed out or something like that. We can actually represent this using sealed classes. And so the way I would do it, I'm going to use a sealed interface actually. Sealed classes are useful if you want to have a common piece of data across all the subtypes. Sealed interfaces are more useful if you just wanted as kind of a handle at the top level. So in this case, I'm going to say response is my sealed interface. So it's just going to be things coming back from my API are responses. So let's think about the types of responses we can get. We can get a response called loading. And let's think about what loading is going to be. We don't need any type of data to say it's loading. It's just the concept of, oh, something's loading. So because there's only ever going to be one instance that makes sense, I can call this an object. If instead I said this is a class or a data class, then what's going to happen is every time we run something, we're going to create a new instance of this loading thing. And they're all exactly the same. There's no data inside this one. So it really doesn't make sense to have to create new instances of this all the time. So instead, what I do is I create a single instance that I just call loading and treat that as though it's every time I'm running, that is the thing that makes it, tells us it's loading. So there's one instance of this class, it's a singleton. Now I can do something similar for object timed out. If there's a request that we want to represent as being timed out. Again, there's no specific data being returned. We're just saying, hey, the operation, the request timed out. I can't do anything about it. And then we're going to have a couple data classes that represent a result actually coming back or an error message coming back. So I could say data class loaded with some data. And let's just say for this example here, it's going to be an integer value that we're getting back. I'll make it a string. We'll be fancy. Boom. and that should be val value. So that represent a, hey, I got this value, boom, everything's cool. And finally, we might have an error class where we have a val message and maybe a exception. Now, just a little note on throwable for exceptions. Some people think it's really a bad idea to catch throwable. I'm not one of those people. I like to have a top level exception handler in my code that will catch throwables just in case anything gets out. And one thing to keep in mind with Kotlin, all exceptions are unchecked, which means you are not required to put a try catch around things. So that means even a throwable can come up to the top level without having a try catch around it. The reason I like to do this is, basically have a top level catch just in case something went wrong, so I can present a nice user message error for the user. And then at lower levels, if there are specific exceptions that I can do something about, I go ahead and do the try catch around those, and then help the user to retry or help the user to understand what they did wrong. But if it's something that, maybe a null pointer exception that happened, I just let that bubble up to my top level thread level exception handler, which, like in Java, you can define what's the name of it? Thread.uncaught exception handler or something like that. And you can do some really nice things like that. In the Android applications that I've worked on at work, we have a top level error screen that can come up. It lists a readable message for the user and then has like a little button they can push to get the developer details and then be able to email that to a developer. And that's really helped us out a lot when things go wrong. So you're going to see some people who are like, oh my God, never, 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 never catch throwable. And depending on what you're doing, I don't like the app to just crash. I like to have it caught at some point. And then there's some other places where I'll catch it at a lower level so I can just log the fact that something happened and then I'll rethrow it. But in this case, we're going to get the exception, wrap it up in this error object, and return it back for somebody to deal with. So if I had something like this, and maybe I have an API that looks kind of like, do I want to do this? I'm going to play a little Weasley words here for a minute. Let's create a data class. Well, actually, no, I know what I'll do. So let's do a fun. What's a good thing here? Let's say get person from, or it's a string, right? Get name from web, or let's say web service. So let's say behind the scenes, this is going to call a web service to get a name, and maybe I'll have an ID being passed in, so you can look up somebody's name by ID. And this is going to return a response. No, that's not. It's going to return a response. I need a callback here because I'm not using. I was going to put a flow in there, and I'm like, no, don't go there yet. We're going to talk about that later. So let's return a callback. Let's see, on response. And we're going to pass in the response and do something with it. So this on response function that's passed in is going to get multiple calls. So we're going to initially say on response loading, just to let them know we're loading the thing. So they immediately get that data back. They can do something with that. Just maybe they're printing the word loading on the screen or something like that. And then get result from web service. So we're going to make our network call there. And let's say let's do a little function here. Get value. So I'm just going to make a little dummy function there that's actually making the call across the network. And I can say val value equals get value. And this could throw an exception as well. Let's put a try around it. And what we're going to do is if we've got a successful value, I'm going to say on response, loaded value, kind of like that. And, oh, I didn't want the null. There we go. So if it's successful, I'm just going to say we loaded the value. That's cool. Here, I'll say on response, error could not load $ID, passing in that exception, just like that. Now, in this particular example, I don't have a timeout, but depending on how you implemented your interface to go on the web, you probably have a timeout in there. And if it timed out, you could just return timeout as well. So what this is doing there. So what this is doing is somebody basically can register a response handler here. And as I get little responses coming back, I can tell them what's going on. So they make this call, they get that information. I tell them what the response is, I tell them if it was loaded or not, and then I tell them if it's an error. Now, most likely, I'd start a thread here. Or better, start a coroutine, which we'll talk about later. Let me use the right word here, launch a coroutine. We're going to talk about coroutines much later in the course, but think of it as just a background thread. And the reason we would do that is when somebody calls this, we don't want them to wait while all this processing is going on. So they call it, telling us what to do when we have a result. We kick off some background processing, and it returns to them. It returns, they're just going to wait for this response to get called, and when the response gets called, they'll have these different values. So this is a place where I really, really like using these objects, because then I'm not creating a new loading instance every single time. And there's going to be, you're going to call this maybe many, many times. It'll save you a little bit of memory, a little bit of speed in there. And then this one gives you a value to do something. Now in the caller might say something like when, let's say val value equals, well, response equals get name from web service with an ID of 42. And, oh, there's actually a, I'm putting that in the wrong spot. I'm so used to doing things with coroutines that I'm thinking of the structure more like a coroutine structure, and I've got to remember this is a callback structure. So we're setting up our callback here to what to do the response. And then inside here, I could say when response is loaded, then we'll do something. Maybe put a spinning progress meter on the screen with word loaded. And what is he not happy about there? Oh, loading, sorry. There we go. So if it's loading, we're going to do that. If it's timeout, we're going to say stop the progress meter and pop up timed out message. So that takes care of our two actual objects. And notice how we're just explicitly using a value. So the when expression says take this and see if it's one of these values. We're just referencing those values. If it's a class, we can say is, and so we could say is loaded. Then we will use the loaded data. And I'll say stop progress meter and use the loaded data, something like that. And in this case, we might actually be locking the user interface as well so they can't tap anything while the load's happening. And if there's an error, stop progress mirror and report error, something kind of like that. And so this gives you a really nice way to handle the results. You don't have to use anything like null to say that it couldn't get data. You don't have to use exceptions and then have exception catching. You just group these things into a set of possible responses from your API. And objects are fantastic for doing that. Okay, so that's one form you can use objects in. Now, another form you can use is for what we would use anonymous inner classes in Java. So let's take a real quick look here. I'll say week 509. I'm sorry, that was a really loud sneeze and you didn't want to hear that. So we've grouped our responses. What we're going to do now is in this Java class, I'm going to create a Java class here. Let's call it user interface. And inside here, we might be setting up some user interface components. Like I might say button. Oh, I shouldn't be using that. I should be using JButton. JButton button equals new JButton. Oh my God, Java is verbose. And then in, whoops, let's use public user interface. I might say button.set, set action listener. Add action listener. Wow, it's been so long since I've done Java. And then we're going to pass in this action listener. And you can implement that action listener in a couple different ways in Java. We could use an inner class to represent it. So I could have a private class button handler implements action listener. And then inside here, we have this action performed function to do something when button pressed. And so if we did it this way, I could actually pass this in by saying new button handler, kind of like that. And now it's using him as a callback to handle something happening on the button. So that is that Java Swing star. I've got to change my defaults in here to not allow it to do that. This is one way we can attach that. But when you look at this, I have to create a whole class just to set up this listener. And that's pretty awkward. So kind of an intermediate step they did was create something called an anonymous inner class. An anonymous inner class just has the code that you want to run. So it's going to have the information about its being an action listener and the function. But it's not going to bother giving it a name. Because if you're only using it once, the name really doesn't matter. So they came up with a nice way to plug it in directly. So I could say button.add action listener. Whoops. New action listener, kind of like that, and then spell it out inside there. So this syntax means create a new instance of some implementation of action listener. I don't care what it's named. And here's the details. And so that is what was called an anonymous inner class. Now, if there's only one function, you could actually replace that with a lambda as of Java 8. Because you'll notice here how it's kind of ghosted out. If I hit Alt-Enter, it can say replace with lambda, and it'll change that, and that's much nicer. But it's the same kind of concept. We're creating an object here under the covers that actually implements action listener, and this is the body of that action function. And this will only work for SAM interfaces. And a SAM interface is single abstract method. So in other words, if the interface only has one abstract method inside of it, you can use this shortened syntax, and that was kind of nice. But it actually does the same thing behind the scenes. It creates a class that implements this, and it has all the same restrictions as an anonymous inner class. If there are multiple functions inside there, so if I had an interface that has more than one function, you have to use this kind of syntax to define it, which is kind of gross. Now in Kotlin, we have much, much better support for how we can deal with different lambdas. But in Java, there's some places where you're still forced to use an anonymous inner class. In Kotlin, if you have multiple functions, you create an object definition inline for it. And normally what I would do in Kotlin is I wouldn't have a single object with multiple functions being passed in to implement. I would just pass in two parameters, two function parameters. And that way it's really easy to implement. You can just say, function 1 equals some lambda, function 2 equals some lambda. But the alternative is to use an object. So let me show you how that looks. And that was in here. No, I want to go in 5. So in here, objects as anonymous inner class replacements. So if I had an interface, let's say sun listener. And inside there I had a fun on sunrise and a on sunset. There's two functions we're doing there. And then I might have a class weather station, which is going to have a private var sun listener, which is a sun listener. Actually, let's make it a var with a private set. Or no, I want people to be able to set it outside. Equals null. And this will allow somebody to set that sun listener inside there. Do I want to do it? No, I want to show you a function. I'll say setup sun listener. It's a little awkward, but I'll show you the two different syntaxes here. And this would end up setting it up so that we can actually listen to the sun rising and setting. In my main, I could end up saying val weather station equals weather station, and then set this guy up. So I could do the same thing. I could create a class that implements sun listener and then set it, or I could say weather station dot setup sun listener object colon sun listener. And here's the definition. And then I'm going to use Alt-Enter here to implement the members. Boom. And so it's very, very similar to the anonymous inner class, but I like this syntax a little better. It's basically saying I'm defining a single object that implements sun listener, and there's the details right there. So this is the equivalent of an anonymous inner class inside Kotlin. And you may have to do this sometimes because you may have an API, especially when you're talking to Java, that looks like this, where it takes an object that has multiple methods. But what I would rather see, if you're really writing this in idiomatic Kotlin, is that we define these as separate parameters to this setup sun listener. So I would have on sunrise and on sunset. Kind of like that. And then, you set them up. So you can use those and just kind of hold on to those as pieces inside your function. I forgot to show you the other version of this, where I just said sun listener equals that, which is a little bit cleaner. But more likely, if you have to use this syntax, it's probably going to be in the body of a function call from Java. So you may have to do this, um, especially like if you're doing things in Android where you have a text watcher, and he has several functions inside of him. Okay. There was one other quick little thing, and then I wanted to call it. Oh, I wanted to show how this setup sun listener looks like. So this one would look like weather station dot setup sun listener on sunrise equals on sunset equals. And this is much more of the idiomatic Kotlin way of doing things, where you just pass in separate functions instead of an object that just holds on to those objects of those functions. Because there really isn't a need to have that separate object just to hold on to these two functions. You can pass them directly as parameters, which you can't do in Java. And that's super, super nice. Okay, and the one little thing that I forgot, I'll do this and then we will call it a day. If you have something that could possibly return a null, or there's just a general test you want to say for the result of something. So this be a good example. Not that one. I guess just look up people named. So what I could do here is I could say, look up people named Scott dot take if, and that'll work on any type of object. You put in some kind of predicate, and we'll say it not equal to empty person list. Then the take if is going to return the value itself that came through if it matches this condition. Otherwise, it'll return a null. So I could say take if question mark dot let do something with it, and then Elvis run do something when empty. So you could do something kind of like that. This take if is kind of nice because you can put it in the middle of your chain to say, okay, I want to split up the action here. On the one hand, I want to do something if the value is an empty person list. On the other hand, I want to do something else. And the take if will return that null. So this is one way if you have like kind of a binary state on things where if it matches a certain condition, do some stuff. Otherwise, if it doesn't, you could even ignore it. You don't even have to run this stuff. You could just do that, saying only if it matches that empty person list, do something. Otherwise, just ignore the result. This lets you have more of a series of instructions for somebody reading the code on how things actually work. Okay, any questions on that? And did everybody get the announcement that the office hours have moved to Tuesday? I can always still take questions after class. I'm happy to. But I moved the office hours to Tuesday just so that you have a little bit of time before the assignments due. Cool, cool. Sounds like it got through. Okay. So hopefully that'll help out and let you. But of course you can always ask questions in the forums or send me an email if you need to. Cool. Any questions? That is looking like a no. Okay, have a great night, everybody, and I will be posting an assignment shortly, and enjoy it. I'll see you guys next week.